Hey guys, welcome to Learn Today IGCSE. This video is a tutorial on Maths Paper 2, Variant 2 from October-November 2023 examinations. Question 1. Write 24.07839 correct to 2 decimal places. This is the second decimal place and the number at the back is larger than 5, so you have to plus 1 over here. So the final answer is 24.08. Question B. Correct to the nearest 10. We're going to do the same thing. This is your nearest 10 and we're going to look at the number on the right, which is less than 5, so we will round it off to 20. Question 2. Write down the number that is 9 greater than negative 2. Greater than means we have to add it up. So negative 2 add up with 9, we're going to get negative 14. Question 3. Find the value of v when u equals to 30, a negative 2, and t 7. Just substitute the values and you will get 30 minus 14, which is 16. Question 4. Change 62,000 millimeters into kilometers. Millimeters to centimeter is divided by 10, centimeter to meters is divided by 100, and meters to kilometers is divided 1000. And you will get 0.062 units kilometer. Question 5. The diagram shows two intersecting straight lines, this one, crossing two parallel lines. Find the value of x. These are corresponding angles. So these two angles here are equal to 114. If this is 114, then this angle would be 114 take away 50 is 64 degree. And now we have these two angles which are vertically opposite due to the two lines intersecting. These angles will be equal to each other, so x will also be 64 degree. Question 6 Part A. Explain why 111 is not a prime number. Prime number are numbers that can only be divided by its own number, and 111 can be divided by 3 and 37. Question B. Find a prime number between 110 and 120. Between this number, only 113 is a prime number. Question 7. Find the bearing of Q from P. When asked to find bearing of a location from another location, for instance here is from P, you should draw the angles at P like this. So you're looking to find Q from P, so from 0, you're looking to find this angle. So we know that the first half is 180, and we just need to find this angle. This here is a triangle. We know that this is 90 degree, this is 39, and we just need to look for this angle, which is 51 degree. But we can't use 51 degree as our answer because we have to start from the north, so we have to add up with the 180 degree over here. So your answer is 231 degree. Next, question 8. Without using a calculator, work out 3 1 over 8 take away 1 3 over 4. Let's first change this into a mixed fraction. For subtraction, we need to make sure that the denominator is the same. So we're going to multiply this by 2. Now that the denominator is the same, we can take away 14 from 25. You need to leave your answer as a mixed number in its simplest form. So this in a mixed fraction would be 1 3 over 8. Question 9. Write 90 as a product of its prime factors. So all these numbers here are prime numbers. So the product of them is 2 multiplied by 3 multiplied by 3 and 5, which is 90. So there you go. So we have proved that. Next, question 10. Expand and simplify. To expand, we're going to open the brackets by multiplying the number outside into the numbers inside the bracket. Now we can arrange the alike terms. So 2t minus 3t plus with 2w's and 3w. You will get an answer of 5w minus 1t. Question 11. The two shapes are mathematically similar. Question A. Find the value of h centimeter. The length of the bigger shape over with the length of the smaller shape should be equal to the height of the bigger shape over the height of the smaller h. So from here we will just use algebra to solve the value of h, which is 3.5 centimeters. Next, question B. The area of the smaller shape is 16 centimeters square. Calculate the area of the larger shape. Okay, first we gotta find What is the scale enlargement from the bigger shape to the smaller shape? So we will use K as the scale of enlargement. So from bigger to smaller, it reduced by 1.8. So we'll do the same to compare the area, except since this is area, area is length times width, so this has to be squared. So we're looking to find the area of the larger shape over the area of the smaller shape equal to 1.8 square. If they ask you to find for volume, then your scale has to be cubed. But if you're just comparing with length, then you can leave your length as the value k by itself. So the area of the larger shape would be 51.84 centimeters square. Question 12. The diagram shows a speed time graph for 16 seconds of a car journey. Question A. Find the deceleration of the car in the final 4 seconds. So we need to find the deceleration over here. The formula is final velocity minus initial velocity over time. So for the last 4 seconds, initially it started at 10 meters per second and then it reduced until 0. So the final velocity is 0. Initial velocity started at 10. Over the last 4 seconds, 12 to 16 is 4. You'll get a value of negative 2.5 meters per second square. But we're using to calculate acceleration here, therefore there is a negative. For deceleration, we can just omit the negative, leaving the answer as 2.5. Question B. Find the total distance traveled during the 16 seconds. For a speed time graph, when you are asked to calculate the total distance, you need to look for the area under the graph. Since we're looking for distance traveled in 16 seconds, it will be from here up till here. So we need to find the area of this whole diagram, which is pretty simple. This shape is a rectangle, so we're just going to use the height 10 multiplied by the length, which is 12. And then we'll add up with the triangle over here, which is 1 over 2 times with the height, which is the same 10. And this time the length is from 12 to 16, so it will be 4. You will get a value of 140. Next, question 13a. Find the value of p. Okay, this is your indices. So the base here is 3. Now let's see if we can change this number also into the base of 3. So 3 to the power of 6 is 729. So now you have all the bases here the same, which is 3. So you can remove the bases and just use the number on the top to solve your equation. So it's going to be 3p. Since this was multiplication, it will be addition for your indices, plus 2p, which is this one, equals to 6. That's 5p equals to 6, and p will be 6 over 5, which is 1.2. Next, simplify this equation. Whenever you see bracket and to the power of, it means that this power of belongs to every number inside. So let's split it. 32 is the first term here, will be to the power of 1.5 multiplied by x to the power of 10, and if you bring it inside, it will be 1 over 5 like this. So 32 to the power of 1 over 5 is 2, and you've got x. Simplifying this, we will get to the power of 2. So your final answer is 2x squared. To answer this type of questions, you need to have a strong foundation on your topic of indices. Here are some laws of indices that you should remember. For the first question A, this was the law of indices that was applied, and for part B, this was the law of indices applied. Question 14. Rearrange the formula to make W the subject. Since W is on this side of the equal, I am going to flip this equation. So we want to make W the subject, meaning that every other term that is associated with W is going to be brought to this side of the equal. First, we will shift minus x to this side. Next, we're going to shift 2. Since the relationship here is multiplication, 2 brought to the other side will become division. And finally, we're going to shift the square. Shifting square to the other side will become square root. And don't forget to write your plus and minus symbol because this is square, so it can either be positive or negative. Next, question 15. On the Venn diagram, shade the region P union not Q. Okay, to solve this question, I like to number all my regions. So the whole thing is 1, 2, 3, and 4. P is only 2 and 3. and Q is 3 and 4. Okay, so P would be these values and union with not Q. So not Q meaning not 3 and not 4. So P is 2, union with 1 and 2. So we're going to shade 1 and 2 only, like this. Next, question B, complete the Venn diagram. Okay, the first information here is saying that the sum of everything inside here is equals to 20. And then the sum of A union with B, and meaning that except this, the sum is 1. So the only region except A union B is the outer part. So we're going to put 1 here. Next, the sum of A is 12. So let's say this is X and this is Y. X added with Y is going to be 12. And then the sum of B, which is all of this, is equals to 10. Let's say this is Z over here. Y plus Z is equals to 10. So 1 plus X plus Y plus Z is 20. We know that X plus Y here is 12. So 1 plus 12 plus Z is 20, meaning that the value of Z should be 7. And the next information is Y plus Z is equal to 10. This is Y plus Z. Y plus Z is equal to 10. So clearly Y here is 3. That leaves us with only X, which you rearrange it, it's going to be 20 minus 11, so it's 9. X is 9, Y is 3, and Z is 7. Let's just recheck our answer. The sum of A is 12. 9 plus 3 is 12. And then the sum of B, all of this is 10. 3 plus 7 is indeed 10. So your answers here are correct. And if you sum all this number up together, you will get 20. Question 16. Find the lowest common multiple of 12x to the power of 8 and 8x to the power of 12. So the lowest common multiple of 8 and 12 will be 2, giving us 4 and 6. Again, it will be 2, leaving us with 2 and 3. So the lowest common multiple of 2 and 3 is 2, which is 1, and 3 cannot be divided by 2, so it will be left as 3. And next, lowest common multiple of 1 and 3 is 3. So 1 will be left as it is, and 3 divided by 3 is 1. So we will find the products of this number. And we've got x to the power of 8 and x to the power of 12. So we're going to use x to the power of 12 here. This is your final answer. Next, question 17, part A. A, B, and C are points on a circle. Center O. Angle OBA is 28 degrees. Find angle ACB, this one. According to circle theorem, the angle subtended by an arc at the center is twice the angle at the circumference. And don't get confused, it can also look like this. So this will be 2x and this will be x. So we're going to apply the same rule here. So the angle here will be double the angle over here. This here we've got a triangle. The lines here are from center to the circumference, so these two are the radius, which means that this triangle is an isosceles triangle. So just drawing it out clearly, if this is 28, this will also be 28. So let's find this angle, 124 degree. So according to the rule of circle theorem, this angle here is double the angle here. So if over here is 124, we'll divide it by 2 to get the angle of ACB here, which is 62 degree. Question B. P, Q, and R are points on a circle. TU is a tangent to the circle at P. Angle TPR is 47 degrees and angle PRQ is 52 degree. Find the angle RPQ over here. Again, to answer these types of question, you must first know the law of circle theorem. When you see a triangle and a tangent in a circle, there are several rules that you should know. The angle over here is equal to the angle over here, and the angle over here is equal to the angle over here. So if this was 47, this would be the same here, which is 47 degree. So from here onwards, we can see that this is a triangle, and the angles here added up together is going to give you 180 degree. So angle RPQ is 81 degree. Next, question 18. A solid cylinder has radius of 5 centimeters and height 8 centimeters. Calculate the total surface area of the cylinder. This is a source that I got from the internet, the formula for surface area for all the shapes that you should know. So for cylinder, this is the formula that we are going to use. You can take a screenshot of this. So for the curved area, the formula is 2 pi r multiplied by its height. And for the circle, it's pi r square. And since we have two sides, top and bottom, we'll multiply this by 2. So adding this up together is 408.4 unit centimeter square. Next, question 19. Find the nth term of each sequence. To do this, we first have to find out whether it is an arithmetic or geometric sequence. So the difference here is similar for every term, which is minus 3, meaning that this here is an arithmetic progression. To find the nth term for arithmetic progression is very simple. What you're going to do is you're going to take the difference, which is negative 3, and then you're just going to put an n behind that value. After that, you're going to find the number before the first term. And over here, we're just going to reverse it, meaning that the number before would be 14. And since 14 is a positive number, we're going to write positive 14. So this is the nth term of this sequence. Next, question B. The difference for each term is not a similar number, meaning that this must be a geometric progression. For geometric progression, I like to do it a little bit differently. So let's first identify what is the pattern here. The pattern here, these are all seems to be like a multiple of 5. And to be more exact, they're actually 5 to the power of 1, 5 to the power of 2, 5 to the power of 3, and 5 to the power of 4. And 1 means 5 to the power of 0. So let's write this into the table. So we can observe that the first term has the power lesser by 1. The second term has a power lesser by 1. The third term also have a power lesser than 1. So this continues, meaning that for n, it will also have a power lesser than 1. And your base number here is 5, so I will just leave it as it is. So the nth term would be 5 to the power of n minus 1. Question 20. The area of a rectangle is 55 cm square. Correct to one decimal place. The length of the rectangle is 9 cm. Correct to the nearest centimeter. Calculate the upper bound of the width of the rectangle. Since we're looking to find the upper bound, we're going to add on half the degree of accuracy. Half the degree of accuracy for this would be 9.5, and for area will be 52.25. The formula of area is length times width. Since we're looking to find the width of upper bound, we are going to find the upper bound area and the upper bound length. We will get a width of 5.8 centimeters. The length of the rectangle was corrected to the nearest centimeter. So we will do the same for the width. Corrected to the nearest centimeter is 6 centimeter. And since we're looking to find upper bound, we're going to add on half the degree of accuracy. So the upper bound would be 6.5 centimeters. Question 21. The line y equals to x plus 1 intersects the curve y equals to x squared plus x minus 3 at 2 points. Find the coordinates of the 2 points. So you have one function and then the other. Just assume that it probably looks like this, and it intersects at 2 points. And these are the coordinates that we are going to look for. When you're given two lines intersecting each other and we are looking to find the coordinates, we are just going to do simultaneous equation. So it's pretty simple. We're just going to substitute the first equation into the second equation. In the first equation, it says that y is x plus 1. So instead of writing y, we're going to use x plus 1. Now we can solve this to find x. We will get x squared equals to 4. So bringing x to the other side, we would get a square root. So x could either be plus or minus 2. So we have two values for x. It could be either positive 2 or it could be negative 2. Now we'll take again the equation 1 and substitute the two values of x's to find our y. So the first coordinate is 2 and 3, and the second coordinate is negative 2, negative 1. Question 22. X is inversely proportional to the square root of w. So x is inversely proportional to the square root of w. we're going to have to change this to equal symbol, meaning that it will be 1 over the square root of w. When given question about proportion, you should always add a constant into your equation. So I'll put the constant like this. It says in the question when w is 16, x is 3. We're going to substitute the value of w with 16 and x 3. If I rewrite this formula, I will get 3 equals to k over 4. Next, we're going to look for the value of our constant. We are asked to look for x in terms of w. So using this equation now, we're going to sub in the value of 12 into the constant. So we will get x equals to 12 over the square root of w. So we have found x in terms of w. Question 23. Some students record their reaction times. The table shows the result. On a histogram, the height of the block for this range interval is 7.5 centimeters, and we are asked to calculate the height of the block for this interval. To answer this type of question, first I'd like to look for the frequency density and the class width. We have already been given the height for the first interval is 7.5 centimeter, and now we are looking to find the height of this interval. To do that, we are going to need our class width, which is 6 minus 0. And for the next reaction time, it's 10 minus 6, so it's 4. Next, we're going to look for the frequency density. To find the frequency density, we will take the frequency divided by the class width. It is been given that for this interval, this is the height. Firstly, we need to find the constant of proportionality. The constant of proportionality can be represented by k. K here is the ratio of our height over the frequency density. So the value of k is 2.5. Now we're going to repeat the same thing for this interval. We have found the value of k, which is 2.5, and the frequency density is 4. So the height is equals to 4 times 2.5, which is 10 centimeters. I think it will be easier to answer this question if you drew this table and understood exactly what do they want in the question. Next, question 24. Simplify. So this question is related to the topic of algebra. Under algebra, you have learned the difference of two squares. For instance, you have two numbers which are squared, and if you factorize it, it can be written like this. For the denominator of this equation is the same as this rule, whereby it is a square minus 1 square. The product of 1 square is 1. So instead of having a square minus 1 square, we can write it as a plus 1, a minus 1. So we have simplified the bottom of the fraction. Now let's look at the top. If we look at the first two terms, they have a common factor of a, meaning that we can factorize a out of these terms. We should also change this into bracket. And now we have the same term on both sides. If I factorize 1 out of this term, I'm still going to get the same value, so I will do that. I can rewrite this top part by grouping the terms together, a minus 1, and since it is multiplication, I can group them together. We can cross out the same terms, and our final answer is x minus 2, a plus 1. Question 25. The derivative of 2ax to the power of 7 plus 3xk is equals to this. Find the value of a and the value of k. So our first step here is going to be to find the derivative of this equation. So we're going to differentiate this equation. I hope you know how to differentiate. Differentiating this will get 14ax to the power of 6 plus with 3kx to the power of k minus 1. Now that we have found the derivative of this equation, we will equal it to this and find the unknowns. So let's compare this. We've got these terms similar to each other. So we know that 14a is equal to 42 and 3k is equals to 15. So the value of a is 3 and the value of k is 5. Last question 26. The diagram shows a parallelogram OPQT. The position vector of P is A and the position vector of T is B. K is on PQ, so that PK to KQ is 3 to 1. This is PQ and this is the position of K. K is located such that the ratio of P to K and K to Q is 3 to 1. So I will write this in fraction. 3 to 1 also means that it is 3 over 4 to 1 over 4. Why I overrid with 4 is because I added these both together. So p to k is 3 out of 4 and k to q is 1 out of 4. Since this is parallelogram, the vector of this and this would be equal to each other. So p to k is 3 over 4b and k to q is 1 over 4b. The lines OK and TQ are extended to meet at x. Find the position vector of x in terms of a and b. Give your answer in its simplest form. Finding the position of a vector is like finding a route to reach that position. So from origin 0 to reach x, you can travel like this. This is just one way. And another way to reach x is if you can go to t, and then you can go from t to x. So writing this in an equation means that to reach x from your center O, you can also do O to t, and then from t go to x. The magnitude of OT, which is this line, is b. And the magnitude of tx is this line, which also means that it is t to q and then from q to x. So tx could also be written as the vector of t to q and then q to x. We know that the vector from t to q is also equals to a. So I'm going to write a here, plus with q to x, because we don't know what is the vector from q to x. Okay, so now we just need to find what is the vector of qx. To find the vector of qx, we can look at the bigger picture over here. Qx is just a smaller triangle of TOX. If I were to split this into two triangles, it will look like this. So what I'm going to do here is compare these two sides. Qx over Qk is just a smaller version of Tx with To. And now let's substitute some vectors that we already know. Qk is negative 1 over 4b, since I'm changing the direction q to k, and t to o is negative b. Since there's negative on both sides, I'm just going to cancel them out. And we know that t to x is t to q, add with q to x. And we know that t to q here is a. Okay, now we can simplify this to find out what is the vector of q to x. Both sides have b, we will cancel them out. And when we bring 1 over 4 to this side, we will get this. Now let's open the bracket and rearrange this. These are both qx, so we can simplify this to 3 over 4 qx. Since we're only looking for qx, we can bring 3 out of 4 to this side. And 1 out of 4 over 3 out of 4 will give us 1 over 3a. So now we have the vector of qx. So qx here is 1 over 3a. Now let's solve this. We can add up these two terms of a, giving us 4 out of 3a. Now we have the vector of ox. Alright, that's all for this video guys. Thank you for watching. If you like this video, please like, comment and subscribe to my channel. Bye, take care.